This is the fifth video in my series on three-phase power transformers. In this video, I'll be looking at harmonics. To be more specific, third harmonics. You can find out more on this subject in my course entitled Electrical Three-Phase Power Transformer Fundamentals. You can access this course and my other courses on my Stan Store at this web address. Harmonic voltages and currents in an electrical power system are the result of non-linear electric loads. Harmonic frequencies in the power grid are a frequent cause of power quality problems. These in turn could result in an increased heating of the equipment and conductors, or the misfiring in variable speed drives and torque pulsation motors. When a non-linear load, such as a rectifier, is connected to the system, it draws a current that is not necessarily sinusoidal. The current waveform can become quite complex depending on the type of load and its intersection or interaction, that is, with other components in the system. All waveforms, no matter how complex, as long as they are repetitive, can be broken down into the sum of the fundamental sinusoidal wave plus multiples or harmonics of the fundamental frequency. In order to analyze this, we have a system of doing that called Fourier analysis. However, just an understanding that complex waveforms, if repetitive, are made up of the fundamental frequency plus integral harmonics or multiples of the fundamental component harmonics. One of the major effects of power system harmonics is the unwanted increase in system third harmonic currents. Third harmonic currents are often the result of nonlinear transformation caused by the hysteresis effect of the iron core. This can cause a sharp increase in the zero sequence current and therefore increase the current in the neutral conductor. This effect can require special consideration in the design of the electric system. We are about to look at one of those solutions, but first let's take a closer look at the third harmonic generated by the nonlinear transformation. If the fundamental frequency is sine omega t, then the third harmonic is a frequency that is 3 times that of the fundamental frequency and can be written sine 3 times omega t. So in a three-phase system, if we place the red phase fundamental frequency as our reference phasor at 0 degrees, then the sinusoidal wave formula is given by A is equal to A sine omega t plus 0 degrees. And I've plotted it on the bottom of the slide. The blue phase fundamental frequency is leading the red phase by 120 degrees, then the blue phase sinusoidal wave formula is given by B is equal to B sine omega t plus 120 degrees. And the white phase formula frequency is lagging the red phase by 120 degrees, making the sinusoidal waveform formula W is equal to W sine omega t minus 120 degrees. Now, keep in mind, we're talking about a balanced system here, so the magnitudes of the A, B, and W phasors are equal, but I'm going to leave them as A, B, and W for now. And the following third harmonic magnitudes, A third harmonic, B third harmonic, and W third harmonic are also equal in magnitude. Now the red phase third harmonic frequency is given by a magnitude A 3H times sine 3 times omega t plus 0 degrees. And if we take the 3 times inside the frequency brackets, it's going to read A 3H sine 3 omega t plus 3 times 0 degrees, which is equal to A3H sine 3 omega t. Looking at the blue phase third harmonic, it can be written B3H sine 3 times omega t plus 120 degrees. Taking the 3 inside the bracket, we get B3H sine 3 omega t plus 360. And 360 degrees is the same as 0 degrees. So the result will be B3H sine 3 omega t. The white phase is given by W3H sine 3 times omega t minus 120 degrees. Bringing the 3 times inside the frequency bracket gives us W3H sine 3 omega t minus 360. Well, 360 is still 0 degrees, so if you subtract 0 degrees, you're left with W3H sine 3 omega t. And all three of the A, B, and C third harmonics, you can see, are equal and in phase. Now, remember what I said, that the magnitudes of the third harmonics are all equal too, so that the third harmonic frequencies are all in phase, and you can see them plotted one on top of the other in the time domain graph at the bottom of the page. So far, this has looked like a lesson in trigonometry. However, simplistically speaking, we have only to understand the results. This becomes very significant when dealing with delta-connected transformers, which I will leave to a subsequent video. As I said before, all of this information can be found in my course on electrical three-phase power transformer fundamentals, which can be found on my Stan store along with many other courses related to this subject. This video is part of my Electrical Technical Information series. In this series, I'll be covering essential topics to help you understand electrical systems. Be sure and stay tuned, as I will also from time to time be reviewing electrical products that, in my opinion, are worthy of paying attention to. Some of those products include 𝐃𝐈𝐒𝐂𝐋𝐀 big and small standby generators. This is the best time to try out any of 𝐃𝐈𝐒𝐂 products because they are having a huge sale starting on April the 4th and lasting until April 21st. Here are just a few of their products, starting with the 𝐃𝐈𝐒𝐂 Delta Pro Ultra, including the River line of smaller standby generators. And a range of portable solar panels. And finally, a unique product, the Wave 2, which is a portable air conditioner / heater. As I said, this is the best time to try out any of 𝐃𝐈𝐒𝐂's products because it is having a huge sale starting April the 4th and lasting until April 21st. During this time, you can experience huge savings off the original market price. To obtain more information on this subject and pick up your free digital copy of the Ultimate Guide to Residential Standby Generators, simply fill out the information requested when you go to this website, https://bit.ly/4/4 Before I end this video, I want to repeat the connection to obtain my free copy of the Ultimate Guide to Residential Standby Generators and receive access to the major April sales on many of the EcoFlow products. Also, here is a connection to obtain a free copy of my 50-page electrical power crib sheets. And finally, here is the link to all of my electrical courses, which are located in my stand store.